Okay, let's unpack this electric vehicles. Honestly, it feels like just when you finally figure out which end of the charging cable goes where, wham, the whole game changes again.
Right.
It's like the tech world decided to mainline espresso and, I don't know, apply it directly to our car batteries. Keeping up is basically a full-time sport.
It really is. The advancements we're seeing, especially in EV battery technology, they're coming at just a blistering pace.
Right.
And that's exactly what we're diving into today. We've got a fascinating report here from Calpurnia News looking specifically at the work of two, well, giants in the field, BYD and CATL.
Absolutely. So for you, our brilliant listener, consider this your mission briefing for this deep dive. We want to, demystify all these electrifying details, really understand the core tech these guys are developing, their pretty ambitious future plans, and maybe even the science behind it all. Think of it as your backstage pass to the future of how we get around.
Exactly. And what's really interesting, I think, is that both BYD and CATL are pursuing, well, really cutting-edge solutions, but they're taking kind of distinct paths.
Okay.
BYD, it seems, is doubling down on refining their lithium iron phosphate tech LFP, while also, and this is big, making a significant leap towards solid-state batteries.
Right. Okay, let's kick things off with BYD then. They're not just, sitting back admiring their current blade battery. Nope. They're already revving up for generation 2.
Slated for 2025.
2025. And this isn't just a minor tweak. We're talking lighter, more compact, and packing a much bigger punch. The stats they're quoting are frankly bananas.
They are pretty impressive.
An energy density soaring up to 160 watt-hours per kilogram. Now, okay, in simple terms, that just means more energy in a lighter battery, right? More range, less weight.
Precisely. And those improvements are really substantial for everyday driving. A lighter battery helps a car's efficiency, obviously, and being more compact frees up space inside. Plus, that high discharge rate they mentioned, up to 16C.
Yeah, what does that mean exactly? 16C.
Well, think of it like the battery being able to deliver a huge amount of power very, very quickly. Super important for things like quick acceleration.
Ah, okay, like flooring it.
Exactly. And then there's a charging rate, up to 8C, which points towards, much faster stops at the charger.
And speaking of fast,
Yeah.
prepare to have your socks electrically knocked off. BYD is claiming they can add 400 kilometers of range.
Get there.
In just 5 minutes.
5 minutes. It's astounding.
That's less time than it takes me to find my keys most mornings. Seriously.
Yeah. Well, this kind of ultra-rapid charging, it isn't just magic, right? It relies on some seriously impressive engineering under the hood.
I bet.
The report mentions peak currents hitting a phenomenal 1,000 amps
Wow.
and power levels reaching 1,000 kilowatts, all supported by a high-voltage 1,000 V architecture.
1,000 volts.
Yeah. Think of it like having these super wide electrical pipes allowing energy to just flood in incredibly quickly. But crucially, this also needs dedicated chargers. You can't just plug into any old outlet. It's an entire ecosystem built for that speed.
So it's not just the battery, it's the whole setup, the pit stop to go with it.
Exactly.
But they're not stopping there, are they? By 2027, they're talking solid-state batteries in their premium cars. Now, solid-state, that's like the holy grail, isn't it?
It's certainly seen as a major technological leap, yes. It has the potential to overcome some key limits of current batteries, the ones using liquid electrolytes, that conduct a sort of goop inside.
Right, the goo.
Solid state replaces that liquid with a solid material.
Yeah.
This can drastically improve safety and potentially allow for much higher energy density.
Safer and more power. Sounds good.
And what's really noteworthy here is BYD's projection on cost. They think production costs for these advanced solid-state batteries could be on par with traditional lithium-ion by 2030, maybe 2032.
Really? Same cost?
That's the projection. If they can actually pull that off, that would be a genuine game changer, making safer, longer-range EVs much more affordable.
Absolutely electrifying news. Okay, let's pivot. Let's plug into what CATL is doing, because they're definitely not just watching from the sidelines.
Not at all.
Their strategy seems a bit different, exploring maybe a wider range of chemistries, including this sodium-ion thing.
That's right. CATL's Nextra sodium-ion batteries offer a really compelling alternative, actually, especially because they don't rely on lithium.
Okay.
They're reporting a range of around 500 kilometers, which is, frankly, quite remarkable for a non-lithium battery right now.
500 kilometers on sodium. Interesting. And charging.
They boast fast charging up to 5C, which, in perspective means they can get a significant charge relatively quickly. Not quite the bleeding edge figures we just heard, but still very usable.
And get this, the cold weather performance. Apparently, these sodium-ion batteries are pretty tough in the cold.
Yes, that's a key potential advantage. They report functionality down to -30, even -40 degrees Celsius.
Wow, that's fantastic news for anyone who's watched their EV range just plummet in winter, like me.
Right. Low temperature performance has always been a bit of an Achilles heel for many battery types. So
Hmm.
this could be a significant win for sodium ion, making EVs more practical in colder places.
Makes sense. But CATL isn't just betting on sodium, right? They've also got a new generation of their own LFP batteries.
Correct. They're second-gen Shaanxi super-fast charging LFP batteries. And here, they're really pushing the charging speed boundary again. Ultra-rapid charging up to 12C.
12C. Okay, so faster than BYD's 8C LFP claim.
Potentially, yes. Their claim is regaining 520 kilometers of range in, again, just 5 minutes.
5 minutes again. It seems like 5 minutes is the new benchmark. The race is definitely on.
It certainly is. And, similar to BYD's approach, this isn't simple. It likely involves very sophisticated cell-level engineering, advanced thermal management, handling all that heat from rapid charging.
Yeah, can't just melt the battery.
Exactly. And optimized charging infrastructure to deliver that power. The fact that two top manufacturers are hitting these kinds of ultra-fast times with LFP, albeit slightly different claims, really highlights the massive progress in that specific chemistry.
They also kind of teased this thing called the Freevoy dual power battery, mentioned a dual core architecture, and hinted at a potential 1,500-kilometer range.
And the 1,500-kilometer range.
That's like LA to Denver on one charge. I mean, obviously still in development, but wow, talk about ambition.
It's a huge number. The dual-core concept, well, it could involve combining different types of cells or maybe even chemistries within one pack
Ah, okay.
to optimize for both energy storage, the range, and power delivery acceleration. If they can make a 1,500-kilometer range practical and cost-effective, well, that would pretty much eliminate range anxiety for good.
You think? Yeah, probably.
And we shouldn't overlook their collaborations, too. They're working with others on ultra-fast LFP batteries aiming for 6C charging. It shows this isn't just an internal race, it's an industry-wide push.
Okay, wow. So we've got BYD pushing hard on advanced LFP and also making a big bet on solid state down the road.
Right.
And then CATL is exploring sodium ion's potential, especially for cost and cold weather, alongside their own really impressive ultra-fast LFP. It really feels like we're on the verge of some major shifts here.
I agree.
So let's maybe dig a bit deeper. Let's compare these two sort of leading edge approaches. Solid state versus sodium ion. What are the real fundamental differences, advantages, disadvantages of each?
That's the crucial question, isn't it? While both are definitely a step beyond conventional lithium-ion, they get there in quite different ways. A really key distinction is the electrolyte.
Okay, the goop again.
Exactly. Or the lack thereof.
Yes.
Solid-state batteries, as we touched on, replace that liquid or gel electrolyte with a solid material.
Like ceramic or something.
Could be ceramic, could be a polymer, maybe a composite material.
Yeah.
And this solid electrolyte also serves as the separator between the positive and negative electrodes.
Ah, so it does two jobs.
Precisely.
Yeah.
Which enhances both safety, no flammable liquid, and stability.
Makes sense. No liquid sloshing around if things go wrong. So how does sodium ion compare on that front? Still using liquid.
Sodium ion, yes, it still uses a liquid electrolyte, much like the lithium-ion batteries we're used to today. The big difference is the charge carrier. Instead of lithium ions moving back and forth, it's sodium ions.
Got it. So different ions, liquid electrolyte. Now, I vaguely remember reading somewhere that sodium ions are kind of bigger, clumsier than lithium ions.
Yeah, that's actually a pretty good way to put it. A sodium atom is larger, and it's about 3 times heavier than a lithium atom.
3 times.
Yeah. And this difference, while it sounds small, has pretty significant practical consequences inside the battery. Those larger sodium ions, they put more mechanical stress on the battery materials as they move in and out during charging and discharging.
Okay, like they're bumping into things more.
Sort of. This added stress can lead to a shorter lifespan for the battery overall. It can also affect the stability of the anode, often made of carbon or graphite, which tends to degrade faster with sodium compared to lithium.
So the sodium ions are a bit like, I don't know, a toddler in a bouncy castle. Lots of energy, but maybe a bit rough on the furniture.
Huh. That's a surprisingly apt analogy, actually.
Thank you, thank you.
Now, contrast that with solid state, that solid electrolyte. It opens up this really exciting possibility. Using a pure lithium metal anode instead of graphite.
Lithium metal instead of graphite.
Yes. And that's a really big deal because lithium metal can store significantly more energy in the same space, much higher potential energy density.
Right.
Plus, the solid electrolyte acts as a physical barrier, helping to prevent the growth of dendrites.
Ah, dendrites, the
Yeah.
battery's little internal villains growing those spikes that cause short circuits.
Exactly, those sneaky little self-sabotage mechanisms. So solid state potentially tackles safety and paves the way for much greater energy storage.
Okay, so safety and potentially way more range. What about just general performance, energy, power delivery?
Generally speaking, yes, solid-state batteries hold the potential for higher energy densities compared to both sodium-ion and current lithium-ion tech,
Okay.
which translates, hopefully, to longer driving ranges without needing bigger or heavier battery packs. And safety, as we said, is a key advantage. The non-flammable solid electrolyte makes them inherently less prone to overheating, fires, explosions compared to anything with a liquid electrolyte, sodium-ion included. Safety and longer range. Definitely top of the EV wish list for most people, I'd imagine.
Absolutely.
Now, how do the sodium-ion batteries stack up on, say, voltage and how much charge they hold overall?
Sodium-ion cells tend to have a lower nominal voltage, typically around 2.3 to 2.5 volts per cell.
Okay, compared to lithium-ion's what, 3 point something?
Right, lithium-ion is usually in the 3.2 to 3.7 volt range. This lower voltage in sodium-ion generally means lower overall energy density and charge capacity for a battery of the same weight and size.
Ah, I see. So maybe great for certain applications like city cars or places with extreme cold, but maybe not the first choice right now for maximum range cross-country trips. That seems to be the current trade-off, yes. What about long-term durability? How many times can you charge and discharge them before they wear out? Cycle life.
Good question.
Solid-state batteries are generally expected to have longer lifespans. This is due to less degradation of that solid electrolyte and just greater mechanical stability within the cell itself.
Okay. Less stress internally.
Exactly.
Yeah.
Sodium ion, on the other hand, because of that mechanical stress from the larger ions hitting the anode.
Bouncy castle toddler.
Yes. They tend to have a shorter cycle life. They experience faster degradation compared to both current lithium-ion and what we expect from solid state.
Okay, so summing this all up, it's clear both BYD and CATL are really pushing the envelope, driving innovation like crazy.
No question.
BYD is hitting hard on improving LFP while looking ahead to that high-energy, high-safety promise of solid state. And CATL is exploring sodium-ion, maybe for cost, maybe for cold weather, alongside their own really impressive ultra-fast LFP tech. It's a thrilling race to watch, powering our electric future.
It really is.
Yeah.
And I think the key takeaway for you listening is that we're seeing incredibly rapid progress across multiple fronts, different chemistries, different designs.
Yeah.
Solid state holds, immense potential, higher energy, better safety, but it still faces hurdles, mainly getting mass production costs down.
Right, the cost factor.
Sodium ion offers a potentially more affordable path, especially using abundant materials with impressive fast charging and that great low-temp performance. But currently, it lags a bit in energy density and lifespan.
Gotcha.
And honestly, the huge leaps in LFP charging speeds we're seeing from both companies, that's massive for tackling charge anxiety, a real barrier for many people considering an EV.
Absolutely. All right, so we've taken a pretty comprehensive deep dive, I think, into these cutting-edge battery techs from BYD and CATL. We looked at their big plans, even got down to the atomic level differences between sodium and lithium.
We did.
Hopefully you, our incredibly well-informed listener, now have a much clearer picture of what's actually powering this whole EV revolution.
And thinking about all this progress, it raises a pretty fascinating question for you to ponder. Considering these rapid advancements, the mind-boggling charging speeds, the emergence of solid state, sodium ion, what impacts, maybe even profound impacts, do you see these having? Not just on how we get around,
Right.
but also on the bigger picture, like energy storage for our homes, for the grid.
Ooh, good question. It's way bigger than just cars, isn't it? It could change so much.
Potentially.
Exactly. So if you found this deep dive illuminating, insightful, maybe even a little bit shocking in the good non-electrocution way, of course, please do give us a like. And hey, subscribe for more electrifying explorations into the fascinating world around us.